Welcome back to Dave Does Math from Home. We are talking about rational expressions. This is part 2 of our video series. In this video, we're going to talk about how to multiply and divide rational expressions. We're starting with the easy stuff. In the first video, we talked about what rational expressions were and sort of how to play with them very vaguely. This video is going to be about multiplication and division. And then we'll do addition and subtraction, the hard stuff. We'll do that in another video. So if we're going to talk about addition and subtraction, the important thing to keep in, we're not talking about addition and subtraction. Wow. Okay, that's fine. If we're going to talk about multiplication and division, yes, that's what we're doing. If we're going to talk about multiplication and division, the important thing to keep in mind about rational expressions is that they are fundamentally fractions. They are made out of polynomials, but they're still fractions. So they have to follow all the same rules as fractions do. So let's briefly talk about multiplying and dividing fractions, and then we'll talk about how to translate that into doing it with rational expressions. So super basic review of multiplying fractions. If you have something like 2/3 times 7/5, multiplying is the easy operation for fractions. You just multiply it straight across, and this becomes 14/15, and you're all set. So no surprises there. If you're dividing things, if you have, let's see, 2/3 divided by 7/5, easiest plan here is just to, instead of dividing by a fraction, you want to be multiplying by the reciprocal. I've heard this sometimes referred to as keep, change, flip. So if that helps you, do that. If you, I hadn't heard that until a couple of years ago. So when I was taught about all of this, it was just you multiply by the reciprocal. That's the words that they used to teach us. So whatever you want to do to remember how to do this, the process is still the same. And then once you're in multiplication, it's back to easy mode, and you just multiply straight across. 2 times 5 is 10, 3 times 7 is 21. That's the super basic version. Here's where things are going to get really interesting. Is that sometimes you're going to be multiplying things like 15/8 times 4/5. And for a problem like this, you could just continue multiplying straight across. Like, I know what 15 times 4 is, that's 60. I know what 5 times 8 is, that's 40. I could do this, but now I have a really big fraction that I need to simplify. Simplifying fractions, just like we did in the first part of this video where we canceled terms, simplifying fractions is going to be a huge part of this section. So my advice is, instead of getting big numbers and then simplifying later, I think we should look at what simplifications can be done right away. Like right here, I see that there's a 4 and an 8, and that's going to cancel and leave me with a 2 on the bottom and a 1 on top. So simplify the smaller numbers before you put them together in the big numbers. The 5 and the 15 will be a 3 and a 1. After you can cancel the 5s out of these guys, cancel the 4s out of those guys. And all you're left with is 3 times 2, or 3 over 2, which I think is nicer than trying to simplify 60/40ths. This is a medium tier example. The slightly more extreme example might look something like 64/75 times 45/28. With this one, you could brute force it, like 15 times 4, 8 times 5. These are not difficult calculations. You can do that and get the 60 and the 40. With this one, I don't know what 64 times 45 is, and I don't want to find out. I also don't know what happens when you multiply 75 and 28, and I don't want to find out. Like, this example, I think, is the most representative of what it's like to multiply these rational functions together. Because with the rational functions, even with very, very simple rational functions, you're going to have to FOIL things, and you might have to FOIL things in a big way. Like if you're multiplying two quadratics together, there's going to be 9 different terms. Don't do that. That's an enormous amount of work that no one has to go through. The smart way to approach multiplying rational functions together is factor everything as much as possible, cancel everything that you can cancel, then at the end of all of that, multiply together whatever is left. So here I see the 64 and the 28, and I think those each have a 4 in them. So 64 I'll write as 4 times 16. The 28 I can write as a, not a 2. The 28 I'll write as a 4 times 7. I could factor these more. I'm just trying to pull out what's the most clear. 75 is, what was that, 5 times 15? 45 is 3 times 15. So if you do it like this, we can cancel the 4s, we can cancel the 15s. Now all that's left is a 16 times 3. That's pretty straightforward. That's going to be a 48. And a 5 times 7 is a 35. And it's already simplified for us. This is the way. Don't multiply 64 times 45 and then try to simplify that number at the end. Don't multiply 75 and 28 and try to simplify that. No good will come of any of that. What you want to be doing is factor first, cancel what can be canceled, multiply the rest. If you've canceled everything that can cancel, the rest will be automatically simplified. This is, if you've already canceled in this step, then this is guaranteed to be in its simplest form from the bat, which is pretty key. I like that. So we're 7 minutes into a video about multiplying rational expressions, and I have yet to write a rational expression on the board. So let's do that. With this bottom example in mind, let's see what happens if we multiply a couple rational expressions together. Or divide them. Dividing them is basically the same thing. You just flip one of them. Let's look at... Let's do x squared minus 25 over x plus 6. We'll multiply that by x squared plus 14x plus 48 all over x plus 5. So, if we brute force this, multiplying this top piece by this top piece is going to be exhausting. We're going to have 6 different pieces. We're going to have x to the 4ths, and then it's probably not going to be in simplest form. So whatever polynomial you get from this product, you're going to have to factor it anyway to try and simplify it. Don't do that. The first step is to factor everything as much as possible. Well, also, maybe the first step is to note the domain restrictions. X can't be -6, and it can't be -5. Some of these terms on the bottom are probably going to cancel, but we have to preserve these domain restrictions. So let's factor this. The top factor is pretty easy. This is x plus 5 and x minus 5 over x plus 6 multiplied by things that add to 14 and multiply to 48. We're real close to 7 and 7. So I think it's probably going to be 6 and 8. X plus 6, x plus 8. If you're looking at these things and wondering how they factor, if you sort of get confused about how they factor, check to see if one of these things is a factor, because these problems are usually set up that way so that like these things cancel. So if you're stuck on this, check to see if this is one of your terms. So with this all factored all nicely, hopefully it's pretty clear that we can cancel these x plus 6 terms. We can cancel the x plus 5 terms. And now all that's left is an x minus 5 and an x plus 8. And honestly, I think you could just leave it like that if you wanted to. X minus 5, not plus 5. X minus 5 and x plus 8. X cannot equal negative 6 and negative 5. I think you should just be able to leave these alone is for your final answers on my math lab. I might be wrong. Check that. If you do have to multiply this out, the good news is you know how. We've done section P4. We know about multiplying polynomials. You FOIL it, you'll get a x squared, 3x, and a negative 40. So it's not a challenge. But it also just might not be something that you have to do. So this one wasn't too bad. Kind of looked a mess at the start, but things canceled really nicely. That's kind of going to be the theme with multiplying rational expressions together. Let's do another one of those. Let's do a division one this time. Division does add one interesting little piece that we should keep in mind. So let's do x squared minus 9 over x squared minus 2x minus 8 divided by x squared minus 2x minus 15 over x squared minus 5x plus 4. So every single piece of this is a quadratic. Multiplying a bunch of quadratics together and then trying to simplify something, still a terrible plan. Let's not do that. Step one, I think, should always just be factor all of these things. So I'm going to factor these pieces first. We'll get an x plus 3 and an x minus 3 on top here. This looks like it's probably x minus 4 and x plus 2. That will give us the negative 8 here and the negative 2 there. I'm going to switch this to multiplication. I'm going to write this piece upside down. So this piece, the x squared minus 5x plus 4, that's going to be an x minus 4 and an x minus 1. And this piece over here should probably turn into an x minus 5 and an x plus 3. Here's the part that's really weird about the division. Now that everything is factored, we can very easily see the domain restrictions. The domain restrictions should be that x can't be, let's see, 4, can't be 4, can't be negative 2, can't be 5, can't be negative 3. Here's the weird bit. Before we flipped this, this was on the bottom. So this piece right here also gives us domain restrictions. So x still, 4 we've already got, but 1. You should add 1 to this list. So when we did our multiplication problem, the domain restrictions came from everything that was on the bottom. When we do these division problems, domain restrictions come from everything except this. So all 3 of these pieces give us domain restrictions. The top and bottom of the right side piece and the bottom of the left side piece. So we have our domain restrictions. There are 5 of them. That's fine. Seems like a long list, but they're all right here. It's not a challenge to write them down. And now we have a very simple multiplication problem with everything factored. We can cancel some stuff. 4's cancel. The plus 3's cancel. And now we have x minus 3 times x minus 1 over x plus 2 and x minus 5. And again, I think you can leave it like this. In case they want it simplified, this would simplify into an x squared minus 4x plus 3 on top, and an x squared minus 3x minus 10 on the bottom. And x still can't be 4, negative 2, 5, negative 3, or 1. And that is your answer. It's not so bad. There's a lot of steps to these, but all the steps are things that we know how to do. We know how to factor. We know how to multiply by the reciprocal, which is just flipping this thing upside down. We know how to cancel factors. We know how to write domain restrictions, and we know how to multiply the leftover pieces back together. So it looks much worse than it is. That is about all I wanted to say for multiplication and division. So I'm going to shut this video down. We're going to go right into part 3 with the next video, where we talk about addition and subtraction, which is, I think, a little bit harder, but still not too bad. So stay tuned for that.